Hello all. In this session we shall discuss about directional derivative. What is a directional derivative? What is the physical meaning of directional derivative? As we have already learnt from the definition of gradient, it is observed that the partial derivative is a rate of change of phi along the coordinate axis. So gradient of phi is dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. So this represents rate of change of phi along the x direction. This represents rate of change of phi along the y direction. This represents rate of change of phi along the z direction. And the idea of extending this to any arbitrary direction makes sense and leads to the concept of directional derivative. So directional derivative measures the variation of a function along a given direction. Coming to the definition of directional derivative. If f is a differentiable function of x and y, then the directional derivative of f in the direction of any unit vector u cap, which is in general ai cap plus vj cap, this is the notation for directional derivative, and this is read as directional derivative of the function f of x comma y in the direction of the unit vector u. So u here is subscript. So it's given by fx of x comma y into a plus fy of x comma y into b. So fx represents partial derivative of f with respect to x, fy represents partial derivative of f with respect to y, which is nothing but dot product of gradient of f dot u cap. This is nothing but the projection of gradient of f onto the unit vector u cap. Note: if the unit vector u cap makes an angle theta with a positive x-axis, then we write u cap as cos theta I cap plus sin theta j cap, and directional derivative of the function phi in the direction of unit vector u is given by phi x of x comma y into cos theta plus phi y of x comma y into sin theta. So phi x represents dou phi by dou x and phi y represents dou phi by dou y. What is the maximum and minimum value of the direction? This is a very important point to be discussed. The maximum value of the directional derivative is magnitude of gradient f, and it occurs when u cap and gradient of f are in the same direction, that is when cos theta is equal to plus 1. As we already know, directional derivative of a function in the direction of unit vector is given by gradient of f dot u cap. So this is nothing but magnitude of grad f into magnitude of u cap into cos theta. This value is maximum when cos theta is equal to 1. We already know the maximum value of cos theta is plus 1. So when cos theta becomes 1 and magnitude of u cap, since it's a unit vector, the magnitude of a unit vector is also 1. So we get the maximum value of gradient of f dot u cap as magnitude of grad f. So in other words, the maximum value of the directional derivative is plus magnitude of gradient f. Similarly, the minimum value of directional derivative is minus magnitude of gradient f, and it occurs when both u cap and gradient of f have opposite direction. This is when cos theta is equal to minus 1, because the minimum value of cos theta is minus 1. Let us look at an example as to how we obtain the directional derivative of a function, a scalar function, at a given point 1, 2, minus 1 in the direction for vector 2i cap plus 3j cap minus 4k cap. So we know this is the definition of directional derivative of a function in the direction of unit vector. So gradient of phi is given by dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. At the point 1, 2, minus 1, gradient of phi is 6i cap plus 9j cap minus 3k cap. In order to find the directional derivative in the direction of unit vector, it is gradient of phi dot u cap. But the given vector is not a unit vector. In order to find a unit vector, it is obtained by vector divided by its magnitude. So we obtain the unit vector by using the formula vector by its magnitude, and we get the unit vector as 2 by root 29 I cap plus 3 by root 29 j cap minus 4 by root 29 k cap. So we have already found gradient of phi at the given point, and we have already just found the unit vector. So gradient of phi dot u cap, the dot product, gives us the value of the directional derivative as 51 by root 29, which is approximately 9.4704. This is how we obtain the directional derivative of a given function in the direction of a unit vector.